Okay, so solving. So now today we're going to be solving. Anytime you're solving an equation, doesn't matter what type of equation, your goal is to get it by itself. Your goal is to isolate. Whatever it is, get it by itself. Okay, that's our goal today. Well, to do that, we have 4 steps. Okay, we have 4 steps. Before we get to those, though, before we get to solving, let's do a little simplifying because you're going to see a lot of these. Okay, so let's look at number 1A, kind of like we've done before with radicals. So if I square something, right, it's the square root of 2 to the second power. What is the second power? What does that mean when I do something to the second power? What does that mean? What does this little guy mean? Times itself twice, right? So that's what I'm doing. So it's the square root of 2 times the square root of 2, right? What did we learn about square roots? Can I multiply those two guys? Yes, I can, because they have the same root, and I get the square root of 4. What is the square root of 4? 2. Okay. Now let's do 1b. Same thing, right? But instead of 4, it's 9. So it's the square root of 9 times the square root of 9. They both have roots, so I can do square root of 81. Square root of 81 is 9. Now here's my question. Is there a shortcut to go from question to answer without having to do any of the middle stuff?
Well, if you know if it's what are those things called? Whatever those are called.
Oh, the perfect squares?
Yeah, you know, perfect square, and it's a square root, and you just say it's the number that's at the bottom.
Exactly. It's you can go from beginning to end without having to do any of this middle stuff. I mean, it doesn't hurt to do this middle stuff, but it's not necessary because anytime I multiply a number by itself, just like Bruno said, I'm going to get one of these numbers here, right? I'm going to get one of these numbers. And when I do that, the square root is always going to be that same number I started with. It's always going to be the same number you started with. The reason that's true is because squaring and square rooting are opposites of each other. They're opposites. They're complete opposites of each other. It's like taking 2 steps forward and then taking 2 steps back. Those are opposites of each other. You end up where you started, right? If I add 10 and then subtract 10, you end up where you started, right? It's the same thing. They're opposites of each other. So knowing that, what is the square root of x squared going to be? Just x, yeah. Without having to do all that middle stuff. Okay? How about this? How about the square root of x plus 5 squared? What do you think? X plus 5. Okay? It just takes away the root. That's all it does. Just takes away the root. Okay? All right. Okay, so now let's get to solving. Solving, we have 4 steps. First step is isolate. Isolate means get by itself. Get the root, the radical sign, by itself on one side of the equation. Okay? Once we do that, we're going to square both sides to get rid of the root, right? To get rid of the root, you square. Okay? And then what we're going to do is solve for x. Get x by itself. It might be a binomial, it might be a trinomial. We might need to use some of the steps that we've used in the past, just depending on what situation. And then number 4 is something new. It's called an extraneous solution. Extraneous solutions are answers. They're answers, but they don't work. Why don't they work? We're going to talk about that. Okay, that's what we're going to talk about today. Okay? All right, so let's try number 2. Number 2, anytime you're solving, you're going to split the 2 in half. Not in half, but, along the equal sign. All right, so it has a root, right? It has a root in it. Anytime it has a root, I'm going to use these steps. So it has a root right there. I need to get the root by itself. It's only on one side. The root's only on the left side. Is it by itself? Is the root by itself right now? Or is there something else on that side? So here's the root. All right, this is the root. Is there anything else with it, or is it just by itself on that side? It's got that -4, right? That -4. That -4 is not part of the root. So it's not quite by itself, right? So how do I get rid of that -4? What's the mathematical way I get rid of that -4? Add 4 to both sides. Yep, you guys have done that before. Okay. When I do that, when I do the opposite, it goes away. I get +3 over here. Still have a root, but now there's nothing else besides the root on the left side, just the root. That's step 1. Done. Step 1 is done. Step 2, square both sides. When I square both sides, it gets rid of the root. I don't want the root. I want to get rid of the root because then I can solve it. So I'm going to square both sides. Okay? You can do that because you're doing it to both sides of the equation. Anytime you do something to both sides, it's okay. So what happens when I square a square root? What is that going to be? There you go. Yeah, we just talked about that. It's just going to be x plus 10. And then 9 squared is, 3 squared is just 3 times 3, which is 9. Step 2 done. Now we got to solve for x. Get x by itself. No more roots to worry about. How do I get x by itself? Subtract 10 from both sides. You guys have been doing that for a while. X equals -1. X is by itself. I'm done. Here's the new step that we've never had to do before. The step is called check for extraneous solutions. Extraneous solutions are answers that don't work. So how do I check an answer? How do I check to see if an answer is correct? You might have done this before, like in Math 1 or even before that in junior high. How do you check to see if an answer works? Plug it back into the original, right? And that's what we're going to do. We haven't done that in a while. But the reason we need to do it is because we need to check for extraneous solutions. So over here, I'm going to check. Let me do a check here. Anywhere I see an x in the original, I'm going to plug in -1. -1 plus 10 minus 4 equals -1. Okay. So I got to do inside the root first. So I get the square root of 9 minus 4 equals -1. Okay, then I do the square root. The square root is 3. Is 3 minus 4 equal to -1? Is that a true statement? Yes, it is. So, turns out -1 is a real answer. It's not extraneous. Sometimes, later today, you'll see, you'll get an answer. You did everything right, you'll get an answer, but when you plug it back in, it just doesn't work. That's called extraneous. Okay? So I have one answer. It works. One box, -1. Enter twice, green check. Okay? All right. Okay, so let's go to number 3 now. Let's jump ahead to number 3. Okay, so number 3 again, it says solve, and it's got a root. So I'm going to draw my line, separate. Okay, the root is over here. All right, that's the root, or the radical sign. Step 1, isolate the root. Is it already isolated? It is, right? There's nothing else. Like the other one had a -4. There's nothing in front of the root. There's nothing behind. That's the only thing on there is the root. So I can skip step 1. Let's go to step 2. square. So I'm going to square both sides. Okay. When I do that, the root goes away. Root goes away. But the other side didn't have a root. So how do I square x plus 2? I'll give you a hint. You've done it many times in this class. How do I square this guy over here? There you go, multiplication box. Yep. So over here, I'm going to make a multiplication box. X plus 2 and x plus 2. Yeah, anytime you need to multiply binomials, we're going to use one of these guys. Okay, so x times x is x squared. Positive 2x, positive 2x, positive 4. Combine like terms. I got some like terms there. So I get 4x plus 4. Okay, step 2 done. Now I'm right here. How do I solve this guy? I'll give you another hint. You've done this many times before too. What am I going to do to solve this guy? Combine any like terms if you can, right? So like terms means the same thing on both sides, on one side. So I don't have any like terms over here. I don't have any like terms over here, right? But I do have like terms on opposite sides, right? So what I'm going to do is use those steps over there. Set it equal to 0. I'm going to set this guy equal to 0. Because when I do that, it's going to make a trinomial. Okay, so I'm going to subtract 6x from both sides. Subtract 7 from both sides. I get x squared minus 2x minus 3. It's a trinomial. It's got 3 terms. It has 3 terms. You've done this the last 3 chapters. We've worked on these guys, so we know what to do here. So if it's a trinomial, first step, it's set it equal to 0. Check. Second, is there a GCF? So do I have a GCF here? Is there anything I can divide everything by? No, right? Okay, next one, ABC. Okay, so I'm going to go over here. I'm going to do ABC. A is 1, B is negative 2, C is negative 3. Okay, let's see. So the two numbers multiply. It's going to be negative 3 and positive 1. Okay, so then I go to the box. So I get x squared. I get a negative 3 here, a negative 3x, and a positive 1x. And then you factor. What times what makes x squared? X. Then I get a minus 3 and a positive 1. Okay. That's factor. How do I solve it? What's the last step to do if I need to solve it? What was the last step we did before if we wanted to solve? Set them equal to 0. Set all of the factored terms equal to 0. Okay, so I get -3 as an answer. And I get -1 as an answer. Okay. All right. Now before I, yep.
It's not negative.
Is it not -1? What did I do?
It would be, you rewrote it incorrectly. It would be x minus 3 equals 0.
Oh, hey, sorry. Yeah, I see it. Thank you. That's supposed to be x minus 3. So I need to add 3. So it's going to be +3. So +3, -1?
Yeah.
Good. Okay. Yeah, no, that's definitely important. Okay, so I got two answers, right? Now, before I go into Delta Math and put two boxes, 3 and -1, I have to do step 4. Check for extraneous solutions. Now, step 4 is not something I need to see. Some people do it on paper. We did, like for number 1, like for the last example, number 2. I did it on paper. That's fine. You don't need to show me that. You can do it in your head if you'd like. Some of you can do this in your head. Some of you can check the answers in your head. That's fine. It's step 4 is not something I need to see. It's something, but you guys need to do it because sometimes sometimes one of these will be extraneous and you won't count it as an answer. So let's check to see. Let's check to see if it works. So 3. If I plug in 3, back to the original. If I plug in 3, right? 3 times 6 is 18. Plus 7 is going to be 25. What's the square root of 25? 5. Okay. And then over here, if I plug in 3 over here, I also get a 5. So I get 5 on both sides. So because I get 5 on both sides, that is a good answer. 3 is a verified answer. Okay. Now let's do the same thing for -1. So if I plug in a -1 here, it's 6 times -1. That's -6. -6 plus 7 is 1. What's the square root of 1 equal to? 1. -1. Plug -1 over here. -1 plus 2 is 1 as well. So they're both verified answers. So on Delta Math, I would put two boxes. 3, one box, -1, and the other box. Okay. All right. Okay, so this is what I want you to do. I want you to do number 4 on your own. I'll give you a hint. One of them, you'll get 2 answers, and one of them's not going to work. Okay. So I want you to try number 4 on your own. We'll do it together in a few minutes, but I want to give you a try to do that one. Okay, so I did the first 2 steps. It was already isolated. Squared both sides. Nice job there. Okay, so now I got to solve for x. So get everything on one side, set it equal to 0. All right, so I'm going to add x to both sides. Subtract 11 from both sides. Okay. All right. No GCF, so I go to ABC. Okay. So A is 1, B is -9, C is 14. So I get 14 and -9, which is going to be -7 and -2. Okay, so when I do that, I get, let's see, x squared minus 7x minus 2x plus 14. I get x minus 7 and x minus 2. Okay. So it's all the way factored. Solve it, set the factor terms equal to 0. So I add 7 to both sides. I get 7, and then I got to add 2 to both sides. Okay, I get 2 answers, 7 and 2. But now I have to check. I have to do the last step, which is check. So when I plug in 7, 7 minus 11, so when I plug it back into the original. So when I plug in 7 here, 11 minus 7 is 4. The square root of 4 is 2. And then when I plug in 7 over here, I also get 2, because 7 minus 5 is 2. So 7 checks out. Verified. Okay. 2, when I plug in 2 over here, I get 11 minus 2. 9. Square root of 9, 3. But when I plug it in over here, I don't get 3. I get negative 3. Negative 3 and positive 3 are completely different numbers. Negative 3 is, you owe me $3. Positive 3 is, here's $3, right? Completely different ideas. So 2 is what we call an extraneous answer. So it's an answer, but we don't count it we don't put it in delta math, because delta math only wants the non-extraneous. So we'd say 2 is an extraneous solution. It's a solution. It is an answer, but it doesn't fit the problem. It's not going to fit the problem because when I check, it doesn't work. So this one, I only need 1 box. 1 box in delta math, positive 7, enter twice, green check. Okay. All right, last one. Last one. Number 5. Okay, so I have a root. So first thing is I got to isolate the root, right? Or actually, I should draw my line. Okay. Is there a way for me to isolate the root? Get it by itself. Well, if there's 2 of them, I can't really isolate them, right? If there's 2 of them, I can't really isolate them. Not like before when there was only 1 of them. So that's why I put if possible. If possible, right? So we can't do that. So we're going to skip that step. We're going to go to the next step. The next step says square both sides. Okay, so I'm going to square both sides. Okay, one side is nice and easy. That's just going to be x minus 10. The other side, is this side over here going to be x minus 2? No, because this guy doesn't extend all the way over. The negative 2 is not underneath the root. So you've actually done this before. You've done a problem like this before. Yesterday, actually, on the review. It's a binomial that you need to multiply. So what you did yesterday is what we're going to do today. You're going to multiply using a box like we did earlier. Okay, so you're going to have the square root of x minus 2 and the square root of x minus 2. We've done this before. So I get the square root of x times the square root of x. What is the square root of x times the square root of x? Isn't this the square root of x times the square root of x, right? This is the same question I'm asking you. Square root of x times the square root of x. It's x. Okay? So this guy is just going to be x. -2 doesn't have a root. X does. So I can't multiply them together. I'm going to do what I've been doing. Put the -2 in front, square root x. Same thing over here. And then the last one is just -2 times -2, which is +4. Okay. Then these two guys are like terms. So how do I combine those two? When I combine those two, what is it going to be? There you go. -4 in the front, square root x stays the same, right? So I have an x, I have a -4 square root x, and I have a +4. Okay. I can't go on to step 3 yet. The reason I can't go on to step 3 yet is because there's still a root. Luckily, there's only one root now. There's not 2 anymore. There was 2 before. Now there's only 1. So I can go back to step 1 now. Now what I can do is go back to step 1 and get that one guy by himself. Okay? Get that one root by itself. So what do I need to do first to get the root by itself? 3 things I need to do to get the root by itself. What's the first thing? Combine any like terms if I can. So when I say combine like terms, it's on the same side. There's nothing on the same side I can combine. But how do I get rid of this 4 here? I'm going to add 4 to subtract 4 to both sides. Subtract 4 from both sides. We get x minus 4 times the square root of x. Over here, I get x minus 14. Okay. Subtract x from both sides. The x's go away, nice and neat. Almost there. How do I get rid of the -4? What am I going to do to get rid of the -4? Not add 4. What are the -4 and the root doing? They're multiplying, right? So I have to do the opposite. I got to do division for this guy. This guy, I got to do division. Okay. So I get the square root of x equals negative divided by a negative makes a positive. And then I can divide them both by 2 to reduce it to get 7 over 2. Okay, so remember, I had to start back up at the top. So I was at the top for step 1. So now I got the root by itself. The root is now by itself. There's nothing with it except the root. So now I can do step 2 again. Square both sides like I wanted to in the beginning. If I square a square root, it disappears. How do I square a fraction? It's easier than you think. How do I square a fraction? You just square the top and square the bottom. So what's 7 squared? 49. 2 squared is 4. I don't think that fraction will reduce, so you're done. But I got to do step 4 now. I got to do step 4. So I really did step 2 and 3 together. Square and solve at the same time. So step 4. Step 4 is check that answer. Now, that answer is kind of ugly. When you check, anytime you check, because I'm going to check over here right now. Actually, you know what? I'm going to check down here. I have plenty of room down here. I'm going to check. When you check your answer and it's a fraction, change it to a decimal. When you put your answer into Delta Math, leave it as a fraction. But when you check your answer using your calculator, your Delta Math calculator or your regular calculator, change it to a decimal, because your calculator likes decimals a lot more than it likes fractions, just like you guys, just like people. Okay? So when I divide it, I get 11 point something? No. 12.25? 25? That's not the answer I'm going to put in Delta Math if it checks out, if it verifies. But your calculator will appreciate it if you do use decimals instead. Okay, so what I'm going to do is I'm going to plug that in anywhere I see an X. So 12.25 minus 2 equals the square root of 12.25 minus 10. This is where Delta Math Calculator comes out handy, so you'll be able to use that. For today, I'll show you. Okay. So the first thing I got to do is the square root of 12.25. Okay, I'm going to go square root 12.25, and I get 3.5. 3.5. Okay. So this guy is going to be 3.5 minus 2. Well, 3.5 minus 2 is just 1.5. Okay. All right, now the other side. I got to do the subtraction first. When I subtract those two guys, I'm going to get 2.25. I do the inside first, and then I take the square root of 2.25. Use my calculator, and I get 1.5. They check out. The answer I get checks out. So I'm going to go put in 49 over 4 into Delta Math, hit enter twice, you're done. Don't put the decimal in, put the fraction in. Okay? So that last problem was kind of, we just had to repeat some of the steps. After step 2, we had to go back and start over again. That's the only thing. I'm going to give you one more like that. We'll be done. I'm going to give you one more like this. Since I only gave you one in the notes, I'm going to give you one more and we're done. Okay? So example number 6. Solve for all values of x. Okay. Okay. Let you practice that one and we'll go over it. All right, so if you're still working on it, keep going, but I'm going to start just so we don't run out of time. So I did step 1. I couldn't really do step 1 because isolate the radical sign, can't really, because there was a radical sign over here and the radical sign over here. So I just squared them. So when I squared this side, it just became x plus 4. But when I squared this side, it looked a little different. Okay, and then I did that, and I stopped there. The reason I stopped there is because now I have to go back to step 1. Because I have one radical sign now. I don't have 2, which is what I wanted to begin with. So I'm going to subtract x from both sides to get the radical by itself. Then I'm going to subtract 25 from both sides. Last step is I got to divide by negative 10. Negative divided by negative makes a positive over a positive. 21 over 10, I don't think you can reduce that fraction. Nothing goes into both besides 1. Okay. All right. The way to solve it is by squaring both sides. When I square both sides, I'm going to get, was it 441 over 100? I don't think you can reduce those. 441 and 100, I don't think anything goes into both. Okay. Luckily, when it's as a decimal, it's 4.41. As a decimal, it's 4.41. Let me double check. Is that right? Okay. Okay. So the last thing I got to do is check to see if that's an acceptable answer. So I'm going to rewrite the original, except anywhere I see an x, I'm going to plug in 4.41. Okay. So over here, the square root of 4.41 is 2.1. Negative 5 plus 2.1. When you do negative 5 plus 2.1, you're going to get another decimal, negative 2.9. Okay. Is that right? Negative 5 plus 2.1. Yeah, negative 2.9. The other side, I have to add. When I add, I get 8.81. When I take the square root of 8.81, I get 2.968. 8.41, sorry. That looks better. 2.9. Again, they're very close, but they're not the same. One is you spent $2.9, $2.90. One is here's $2.90 credit. They're very different. So they're not equal. So this is an extraneous answer. Let's say you get this on Delta Math. What do I put as an answer? An empty box. You literally don't put anything in the box. You hit enter twice, and that's the answer. Yeah. As crazy as that sounds, you just leave it blank. You leave the box blank, hit enter twice, and you're good to go. Okay. All right. Okay, tapes in the back. And tomorrow we'll do some practice, and we'll be done. And we got one more lesson on Thursday, and then we're done with this chapter.